Good to be back. I was at the last one, and Nick told me that I should talk, so here I am giving a talk. But yeah, so I work at a company called Beehiv. I'm going to go through sort of the intro of how I got here, the problem that we faced, why we ultimately chose ClickHouse to meet our goals, the solutions that we built around it, and where we've hit some bumps, and also the positive stuff that we think we're going to be building in the future around ClickHouse without giving away everything. My name is Jacob Wolf. I'm a senior solutions engineer at Beehiv. I just noticed I was blocking that. I am a former award-winning investigative journalist. I used to work at a little-known company called ESPN and covered the gaming industry. In 2022, I went independent and launched a newsletter on Substack. I was the first person in the gaming industry to partner with them for their Substack Pro program, which is a program where they support journalists with additional infrastructure around you, legal costs, etc. And at the end of that time in April of 2023, I hated Substack and I wanted to move on. And so I started calling around in the media industry and talking about where I should go. And a guy that co-founded Puck News said you should meet one of my mentees. His name is Tyler. He runs a company called Beehiv. And so Tyler and I talked. I moved my newsletter to Beehiv, and then 8 months later I found myself working here because I was super passionate about what the company was doing and wanted to get involved and help build as a media person, media SaaS. And so prior to my journalism life, I was a developer. I went to school I did 2 years of school for prereqs to go into computer science, but my journalism career took off while I was in school, and so I dropped out and did that instead. But I primarily write TypeScript, Ruby, Go, and PHP. Day-to-day, mostly TypeScript and Ruby, which is what the main Beehiv app is built on, but some of our microservices are built in those other languages. And then, I also lead Beehiv's integration projects. So currently, we recently built a connector to StockTwits, which is like Twitter, but for stocks, like a marketplace to talk about stocks. And then throughout this year, as early as next week, are launching additional integrations for us to plug into other platforms. And so doing the bulk of the engineering work on that, and is also leading the strategy. So what is Beehiv? As you can guess by my intro, we are an email service provider. We really like to position ourselves in the middle of something like a MailChimp or a Sailthrough, these like really high-end, high-grade, and extremely difficult to use platforms for sending email, and places like Substack that are very feature poor and do not have a lot of feature sets. They really just can send email and that's about it, and post to the internet. And we like to be somewhere in the middle. We want to be able to support the largest enterprise customers that have used those solutions like MailChimp and Sailthrough, while building something that is easy to use, that if you are a solopreneur or an independent journalist, that you can jump in and learn this platform, and also how to build a real media business around yourself. So some of our largest customers: Time Magazine, The Ringer, which is the Spotify-owned sports vertical, the Texas Tribune, right here local, and Brex, the credit card company. We were founded in 2021 by 3 of the engineers who worked at Morning Brew. Morning Brew is probably one of the 3 people that really innovated in the tech space around newsletters in the late 2010s. Or mid to late 2010s, and the 3 guys that are our founders really wanted to take that technology that they built for Morning Brew, referral programs, and various other analytics stuff, etc., and take that and build that in a box and sell it as SaaS. That's how we got here. We send roughly 2.5 billion emails a month on behalf of customers. And you'll see later how much event data that results in. And then across our network, we have roughly 500 million subscriptions stored on behalf of our customers. When the company started, as anyone who's ever worked in startups knows, you build for what you know and what works at the time. And so the 3 guys that started our company were not data engineers. They did not expect a company to be sending more than 1 billion emails a month on behalf of customers, so they built something that worked, which was a Ruby-based API that sat on top of a Postgres database to basically take in webhooks from our upstream provider, SendGrid, and take it and do a couple different things with it. So actually ingesting and storing those things, clicks, opens, deliveries, etc., all the things that happen as a result of an email, and then enriching them, doing aggregations, etc., attempted in real time, which we'll dive into in a second, but in many cases having to be computationally aggregated on some regular cadence. It was responsible for aggregating kind of the most important stats in the app, which I'll show the app here in a second, including our publication dashboard, so a high-level overview of how everything on a publication is performing, how a specific post is performing, and how each subscriber in a publication, what is going on with them in terms of their open rate, click rate, all of the event data, so a timeline of everything they've done, clicks, opens, deferrals, bounces, so on and so forth. And what the guys built is an incredible feat of engineering work. I think that we've all encouraged them to write a retrospective, and they've not yet, because to scale Postgres and Ruby to do more than 1 billion events a month is crazy. And more than 1 billion events a month is crazy, and ultimately is not scalable though. But they really stretched it, I think, about as far as you can go before you get into moving to an OLAP provider like a ClickHouse, or sharding your database, which is what Figma ended up doing when they got to that size, is sharding Postgres. So we had the problem of figuring out how to deal with this. I wanted to quickly kind of show a little bit of the product itself and what this data is used for and how it's put to the test. So this is Beehiv. As you can tell, so we have these aggregate dashboards, and so we have active subscribers, open rates, click-through rates, charts that are built off of those things. If I scroll down a little bit, you'll see, let me go back to like 12 months. So we have those charts. We have this impact pie chart that is basically how you are getting your subscribers, so the UTM information that's being collected that you're either passing to us via API, or if you use, because we have a website hosting product too, if you're using our website hosting product, where those subscribers came from, and storing and then computing those. We are primarily using our data for a couple different things. So if I go into a post and I find a sent post, we are using it for stuff like this. So recipients open rate, click-through rate, etc. Through email, and then also, which I'm going to dive into when we talk about replacing merge trees, verified click data as well. And then we also have, let's see if one's been built in this account, in this demo account. Yeah. So we also have segments. So this is the ability, basically like a layer that we built, visual layer and Ruby layer on top of SQL, that you can basically give us a set of parameters, because we have custom fields and subscriber tags, and also all the event data, so open rate, click rate, has opened this email, hasn't opened this email, etc. It's basically a query builder that you can build segments, and then you get analytics data for each of these segments. You can use them to send out to specific segments, to exclude specific segments. We also have automations. You can feed one of these into an automation. And then high level, also we have like our main dashboards, which are here. I'm going to go back far enough so you can see. 180 just to be safe. And so you can see like the subscribers that are coming in, the posts that you have sent. You can see your post performance. We've not sent anything on this account in the past 30 days, all time. So you can see stuff like this, and we're computing. The nice thing is we're computing all of that in real time nowadays, which is great. There are very few things in our app nowadays that use caching for analytics. Almost all of it is done in real time. So the goals when I first joined the company in February of 2024, I couldn't wake up a single morning without a hair on fire issue resulting from the honeycomb system I mentioned earlier, where there was always some sort of lag, whether it be events were being dropped because we had too much throughput coming in on webhooks, whether it be the aggregations were really slow in terms of being built, or in the cases where we attempted to use it in real time, customers having a lot of delays or just being canceled and timed out just straight up. And so every morning was a hair on fire. In the summer of 2023, our leadership team recognized that this was going to be an issue at the current scale. So we hired a head of data and infrastructure to come in and build a team, who hired 2 additional data and infrastructure engineers to figure out what the hell are we going to do about this. And the goal was to build a new infrastructure and data platform that allowed for those real-time analytics that you just saw. Instead of doing what Honeycomb did, which was jobs, it would take in a bunch of this data. It would either temp store it or find other ways to batch it, and then like batch write. Had the ability to do basically streaming and stream in all the various different events. And then once they reach a certain amount, then batch instead, rather than being reactionary. And then have resiliency. The Postgres database, because it was so damn huge, went down all the time with Honeycomb, and so not to have that, have it actually like be able to stand up and replicate and spin up nodes and scale as it needed to. The sort of business benefit to us as a company is we had a lot of engineers who were not focused on that problem, that were constantly being pulled into solving that problem every single morning. I feel particularly bad for our 2 European engineers who had to deal with that while most of our team was offline. We wanted to build more ambitious features. It was even clear back then in summer of 23 and early 2024 that we were going to be selling up market and getting adoption up market from big media publishers. They have lots of feature ideas all the time. We have no shortage of them. And there used to be a concern of if we built this and it uses any sort of like large scale event data, can we actually do it? And we don't have that anymore. But then also the ability to do internal reports. You used to go look at a chart internally, and it would take 10 minutes to load these long pieces of data. And when we were trying to get a good sense of how the network was performing, we also, for those largest customers, many of them want the ability to like email us and get certain sets of data, or want us to be able to send it over in some cron job or whatever it may be. We used to be concerned about how much computation that would take and how much bandwidth that would take away, but now we do that pretty frequently. And then also, the last thing I'll talk about towards the end, we wanted to start using ML. So one of the things I didn't mention at the top of what we do is that we have an ad network. Think about it similar to Facebook or Google in the way that they sell advertising. So we have access to all these publishers with a ton of volume and placement. Ironically, despite newsletters being such a old thing and email being such an old part of media, a lot of these large media companies have no idea how to sell their ad inventory. So we have a really cool spot of being able to like have educated email ad sellers that go and sell to big brands like Nike and others who have Netflix, et cetera, who have sponsored us over the past year. And then we go and provision those deals to our publishers. And we currently but are building new ways to do this based off of the strides we've made on the infrastructure side of things. Currently, those were all manually provisioned. So literally just an employee sitting there going like, oh, I think this person should get this ad, and I think they should get this ad, and I think they should get this ad. It takes a lot of time. And so we wanted to start building ML without paying an Elastic or OpenSearch a ton of money, or hosting them somewhere we'd have to pay a ton of money. ClickHouse is a great solution for that. It's pretty good as a vector store. And then similarly, when you get to this size, you have a lot of people, and you have publishers the size we do. You have a lot of people that want to do spammy, fraudy stuff, and you need to be able to identify their types of behavior and action on that. Again, vector-like storage. So the solution that we came up with was we are using Kafka. Kafka takes in all this event data that we are receiving from SendGrid. It takes it, and then at a certain point, there's a series of microservices that are written around it that do a mix of actual writing, batch writing, in distribution to ClickHouse, as well as I'll dive into in a minute with the merge tree, or replacing merge trees, the ability to take the data, do computational analysis on it, and as you heard in the previous talk, write the exact same data, but with different values and different columns, and ClickHouse will recognize, hey, I know that ID, let me check that out. But then we can also immediately write or near immediately write what we receive raw, and then take it and do compute on it, and then store it again. And this has been super, super effective generally. We've had very little downtime, as I'll talk about here in a second, and it's definitely not from this. So yeah, as you heard in sort of the previous talk as well, there's sort of two types of databases. There is row-based architecture, like a Postgres, MySQL, SQL Server, etc. And these things are fantastic for some cases, and I won't say we don't use them, we do. We actually have a very, very large Postgres instance also that still runs primarily for user metadata. And because we have a Ruby on Rails application, something I'll talk about later, it plays very nice with Postgres. There's not a lot of things. It's very good for single writes, etc. Where it starts to fail is when you start doing large things like counts and various different aggregations, or you're taking these very, very large data sets. And crucially, in many cases, as says on the slide, it might be reading stuff you don't actually need. So in many cases we saw, if you looked under the hood, our Postgres instances were pulling data that I had no necessary reason to be pulling in this, whereas when you get to what ClickHouse is, a column-based, column-R-based OLAP database, it is partitioned by column and partitioned by key. And so you have the ability basically to do, I only need this one little piece of data, and that data comes back really, really fast. One place that we saw basically immediate improvement by building was we used to have you saw it on the dashboard, the active subscriber number. We used to have to aggressively cache that number when that was done in Postgres because the count was really bad, and then we turned it into a view, still wasn't great, and now we have a ClickHouse version of that query that is the default in the app, and it will run, and it has some caching on there, and we don't want people to just constantly, every time they hit the dashboard, to just like constantly request a brand new count all the time, but it's much lower, therefore the number they are getting is much more recent and new. One downside here, and this is part of the reason we've not moved everything to ClickHouse, is that one of the nice things about a Postgres database in particular is the ability to do rollbacks. So I have recently been spending my time rebuilding our custom domain architecture. So we have, functionally, we have 4 different types of custom domains that we host on behalf of customers. We have email domains that we send email, and we're releasing the ability to send multiple sending domains. And so with that, we are creating a bunch of different records. We're doing a bunch of other things, external APIs, SSL certificates, etc. And if one of those things fails, we need to be able to abort and go all the way backwards. Postgres is really great at that. OLAP databases are not so great at that. And so some of that stuff that is not sort of event or analytics related, we still store in Postgres. But generally we are, as I'll talk about later, slowly trying to move as much of the stuff to ClickHouse as possible, and pending developer adoption, which I'll talk about a little bit later as well. So ClickHouse, you already heard a little bit of this, so I don't necessarily need to repeat myself, but ClickHouse has the ability to do automatic materialized aggregations really nicely. We have the ability to support those real-time analytics that you're seeing in the dashboard. One of my favorite things about ClickHouse is that I personally really like the query syntax, but I know a lot of people that come from SQL don't. It very much reads like C. because that's the language it's built on. But you have a handful of different functions that are estimates that get you close to a real number if you don't necessarily need the real-time number. Or you can do conditional counts, etc., unique exact if, which I've been using a lot recently for a couple things in the app. Yeah, it's just very, very helpful. Lag and frame, which I'll talk about in a second, lag and frame, lead and frame, which is really nice. And then, yeah, as mentioned in the previous talk, compute and storage are completely separate. All our data, we do use ClickHouse Cloud. I'm sure someone's going to ask that, but we do use ClickHouse Cloud, but we use it on top of S3. We bring our own S3 storage to the cloud, yeah, the compute and the storage are completely separate. When I looked earlier today, we have in our main table, we have, I think, maybe like 60 tables in ClickHouse at the moment, but in our main table, I think it's something close to like 88 or 89 billion rows. It's a lot of rows. And then, yeah, ClickHouse is open source, so our, I don't know about you guys if you've worked in big engineering industries, but it's always scary when you adopt a solution that's not open source because you're like, what is going to happen to this company? ClickHouse is fine. They're doing well for themselves, but nonetheless, if things went tits up, we can figure it out. The code is open source. And then, yeah, there's a growing number of integrations and data types and built-in analytics functions. We've been using the S3 merge tables a lot, in particular on behalf of some customer data, which I can talk about a little bit if you'd be interested. And it's really cool that, like, I don't have to go pull that in memory in Ruby and then take that and fish it off to S3, that ClickHouse can just do it for me if I tell them how to do it. So yeah, as I said earlier, we use the replace merge tree table engine a lot. So one thing that we do that I don't think maybe one other people in the ESP space do is we put a lot of time into verified clicks because we have the ability to, or because we have an ad network that pays out both CPC and CPM. It's really important that we internally and also these big publishers that are going to sell their ad space have real numbers. There are many places in email in particular because of firewalls, both the commercial ones like Proofpoint, which many of the Microsoft Outlook senders or the people that use Outlook Enterprise use under the hood, as well as a growing number of independent ones or a growing number of like not open source, but like free to use email providers use, like iCloud does a lot of like bot click, etc. stuff because they're trying to make sure that what you're sending is not phishing prior to delivering it to the user. And so as you can imagine, you see a huge spike in these numbers. And so we spent a lot of time after migrating our event data to ClickHouse to building verified clicks models, which I'm actually speaking about next week at an event here in Austin at the Omni. But we essentially have internal data and external data from vendors that we will take, and in the hours following the initial write to the table, we will pipe that data off, we will do all the computation that we need to do around it, we will enhance it, and then we will come back and write the same piece of data again, but now enhanced with the verified click logic and other things, which we show in-app and also deliver to customers in various different ways. Also, similar to the previous talk, we also do use we use Debezium. We actually do self-hosted Debezium. And it's been pretty stable for about 3 or 4 months now. It was not so stable when we first started, but we put all those engineering hours she was describing into it, so it's good now. Yeah, we used Debezium to sync from our Postgres database to ClickHouse. And in some cases where the tables are smaller in Postgres, we're mostly doing that for the heavy, like our subscriptions table and other things that are these large tables with a bunch of records. In other cases, ClickHouse has had the ability to directly connect to Postgres, and so we do that for the smaller tables rather than doing the replication. Yeah, and then also really, really important here on the merge tree while we're talking about it, one of the scariest things when I started was that aforementioned Ruby Postgres app would, if it lost, like SendGrid would repeat events, etc. for us, and we could query them via API if we actually absolutely needed to. But in many cases, the scariest part was potentially losing data. So if we had downtime, if we had scaling issues on that old infrastructure, it was really, really easy to lose pieces of data and have to go ask for it later and then backfill and all of this other stuff. That doesn't really happen here. Kafka's been very good about the distribution and holding things in places and keeping it in temporary memory until it offloads it to ClickHouse and confirms that it has been stored there effectively. And then again, we can just store partial data and then go back and rewrite it or overwrite it again anyway. To that point, also the ephemeral columns are really, really helpful. So we do like geolocation enhancement, etc., because we get IP address and other things on click data. So we definitely don't have where someone is located the minute we first write that, but we do have that from dictionaries. And so we use the dictionaries to write those things, and ultimately they do become materialized in due time. Same for like, same thing for like ISP and also for user agent and other things that we want to do a little bit more analysis on. Really, really helpful for that. And then window functions. So I mentioned these earlier. One of my favorite things about ClickHouse actually is the way that lag and frame and lead and frame work. Generally, this has been so helpful. Trying to look at a big piece of data and filter in this type of way in Postgres is really annoying and really slow. This has been really, really helpful to be able to take, maybe I don't even want the actual one that I'm referring to here, but in many cases I do. And before we built a microservice for that verified click logic that I was describing. Before we had that, we were actually just using these functions to like do stuff like, oh, did it click 6 times in a row in a span of 4 seconds? Yeah, that's probably not a real human being. This was really helpful at like taking and figuring that out prior to having a more sophisticated system, or at least making a very well-educated guess. So yeah, the results is we do 7.2 billion events a month every single month now. That is compressed is 4.4 TIP, and then also 39 uncompressed. We pay for a lot of storage, but it's okay. This is I'd rather be in that spot than hair on fire every single day. Frankly, the downtime that we have had is almost all self-imposed. It is very rarely an issue of ClickHouse or the storage provider or any of the other pieces in the middle. It's like, oh, like we pushed some buggy code or we pushed something that wasn't optimal and it's sitting there running a bunch of times in the app. Like, yeah, that makes sense why that wouldn't work. But in many cases, throughput has been pretty good. We do not have the hair on fire analytic stuff anymore, and we haven't since we started doing, the system started being built closer to the end of 2023. It was like production ready for certain pieces by about July or August. And then we had everything moved over by October of this past year. So we've been on the brand new system for about 8 months now. And yeah, it's been great. And I think to my earlier point, we have a lot of new ideas of what we can do with it. And the fact that it can support the load that we throw at it is great, generally. But don't still be optimal. That's the one thing I think people with ClickHouse are, that use ClickHouse are not good about is they're like, this thing's so fast, I can do whatever stupid query I want. No, still like do subqueries, do other things, like actually be an efficient data engineer. And so, yeah, to the point we have far less fires. Here you can see sort of that's our primary table there and the results of how it's performing. It's extremely fast. Those are a little bit older numbers too. I think it's even faster than that since we've gotten better at both our throughput and also the queries that are querying that table from our main application. It's extremely performant. And then yeah, we are almost always no more than four seconds behind wall clock time. So yeah, and to the point we used to have put up banners for hours every single morning. Not a great look when you have to tell your customers, hey, those numbers you're seeing on your dashboard are out of date. But we don't have to do that anymore. Those banners have since gone to the wayside. So yeah, the sort of some of the hurdles that we've had with ClickHouse generally, ClickHouse's support for ORMs is not great, especially Ruby, to be frank. I think Active Record is one of the best things to ever happen in engineering generally. The ability to make SQL much more legible and easy to use for developers, regardless of how far they like understand data, is really, really great. We use a gem that is open source, not made by the ClickHouse team, for Ruby. And like the fact of the matter, to the last point, is that ClickHouse has all these crazy functions that only exist in the context of ClickHouse. They're amazing. They like speed up your query time. They do all sorts of efficiencies and aggregations in a way that a normal SQL database cannot. None of those are available in the ORM, and so you find yourselves in many times writing SQL strings and then doing like a sanitized SQL at the end, basically like substitute in the values. Even better if you can get the values out of Postgres quickly, so you make the ClickHouse query even more efficient, so it's not having to go fish, because to the earlier point in the earlier talk, ClickHouse joins suck. But I know that the ClickHouse team has been working on making them a lot better, so I do appreciate that. I don't want to ignore that, but ultimately the thing I found to be most efficient in ClickHouse is when you do a bunch of subqueries beforehand. So you just do, all your subqueries, as she was saying earlier, take and get the keys that you need from doing the joins, and then have them and then substitute them in at the end. That results in generally much more efficient processing. But if you just start doing join, left join, inner join, whatever it may be, like, you're going to be sitting there for a while. So that is rough. And I think generally, to the earlier point, it's different. And if you've ever worked in a big engineering environment, people don't like different. Engineers are creatures of habit. They do not like change. And so while we've got our most senior non-executive engineer is like a ClickHouse wizard. He's great. He has rebuilt all these queries from Postgres and the old Postgres system to ClickHouse. He's built some really great stuff. But outside of him and a handful of the others of us, maybe a handful and a half of the others of us that use it pretty frequently, like a lot of people are like, oh, I'm just going to write stuff to Postgres. And then we find ourselves in the same problem that we have, where generally we're sitting here like, oh, we wrote a bunch of data to Postgres. We're now trying to query this large thing of data. It's really slow. This is not great. And the answer would have been ClickHouse originally. And I think one of the things that could improve here is that I took the ClickHouse developer course last summer, which was wonderful. It's free. You should do it if you've not. You will learn a lot. It's like 3-day intensive thing, maybe 4-day intensive thing. And one of the things that ClickHouse encourages you to do is batch insertion, which I totally understand why, but that's hard when you're running like a standard application, because I have front-end endpoints that need to hit a controller, and that controller needs to run a service that writes one thing and one thing only. And that's pretty easy in Ruby just generally, but not so great when you try to do that with ClickHouse. We don't do a lot of telemetry from our main application to ClickHouse. We mostly use it to query ClickHouse, and we use other microservices, Kafka, et cetera, to write to ClickHouse. But yeah, so in most cases we don't do insertions. I would love to do more of them, but that means like the couple of times we've done it, that means we like write an ingestion service API endpoint that then is hit, that then does the processing and batching and does the writes to ClickHouse. And you want that for like things that are really, really high throughput, whereas like Postgres, it doesn't care. Like if you just write one record on a table that's not got a lot of records, that's cool. Yeah, ClickHouse is much preference of, it actually really likes the high volume. But one of the real benefits is infinite scale. We've really started getting more and more aggressive with what we're building around data. I was telling Tristan earlier that like one of the things that we're doing this year is we're going to be building more and more data connectors to other systems. I've already built one for S3 that is on top of ClickHouse. Where I am running a job in Postgres, that uses like a Postgres record to identify itself, and it's running a cron inside of Sidekick, the Ruby job scheduler, and then after that initial record is created in Postgres, it spins up a DDL. DDL goes off to ClickHouse, and the table is created on behalf of the customer. And then we have a cron that says, okay, for every single record in that Postgres database, I want to make a ClickHouse query that also pipes off a bunch of data from our ClickHouse instance to that table, which then writes and partitions automatically to Amazon S3, to the customer's Amazon S3, which is really, really helpful, because then they can take it, throw it in Snowflake or BigQuery or whatever they want to do, and ingest it and digest it. And I think some of them even use ClickHouse in their own instances, so taking it and taking the data we send out of ClickHouse to then ingest it into their own. And so we're doing stuff like that. We're building more and more like data lake connectors and other things, because as we go up market and we have more and more of these larger customers, they want to be able to take all of their email data and pull it. And then the other thing we've been thinking about is webhooks and APIs. How do you get that type of data out? Could have never had that conversation a year ago, because it would have been like, okay, like it's already bad. If we put a lot more throughput of like customers that may or may not reliably figure out how to query this stuff, it's probably going to go pretty badly if they just like don't understand exponential backoff and they're just like constantly hitting these endpoints over and over and over again. Not really a concern anymore, generally, unless the query is really, really poorly written. But assuming the query is well written, as in many cases in our instance, it will be okay. And then the last bit that I don't have on here is talking about that machine learning side of things. So our dynamic segments that you saw there in the segment builder, those currently rebuild once a day, unless you ask them to manually recalculate. So those rebuild about every morning. And they'll be pretty fast, though it's running lots of them, hundreds of thousands, if not millions of segments every single day. And they all have their underlying different queries. However, the customers, built the query themselves inside the query builder. The goal is, I think, to make those basically real time, and so that they can constantly update. And I think that's something that sort of the ClickHouse infrastructure and architecture will allow us to do. Similarly, we have automations. They do have real-time triggers from things like upgrade and downgrade events on paid subscriptions, etc. But we would like them to have click triggers. So someone clicks a link and then they're immediately thrown in the automation. That is also another thing that is going to need to be able to use real-time event data. Something that I think ClickHouse will empower us to do. And then on the machine learning side of things, as I mentioned, auto provisioning for the ad network, etc. Some of these other cooler things that we're working on that are all using. Our primary machine learning engineer didn't even bother figuring out vector, whatever vector storage solution we have. We have OpenSearch that runs on our Postgres stuff and our Postgres data, but he didn't bother. He just used ClickHouse and just started using it straight out of the box, and it's been really, really great for him. So so that's all from my presentation. I'm happy to take any other additional questions.